everybody. We're almost finishing React Miami, and I hope this presentation is interesting for you. So yeah, today I'm going to talk about WebAI, and it's building the next user experience in the browser. And this talk, I pitched it last year, and as AI changes so fast, I've been changing a lot of the content to make it more up-to-date for you, and it's actually valuable for you. And I want to focus on how the user experience have changed, and if you were in the panel, they talked about some of those things. And you as a React developer, you use the browser, and that's what I want to teach you today. Like, with your knowledge, you can create AI solutions and in the browser. So I hope this is exciting. So who am I? I already mentioned. I'm Aileen. I'm a software developer at Orama. If you've used Tanstack Query, so you have seen Orama as the search engine there to find things. I'm based in Mexico. I'm passionate about AI and web technologies. I organize various meetups in my city. So if you ever want to host a meetup in Monterrey, I'll be delighted to host it. And yeah, a Women Techmaker Ambassador. So yeah, the web has evolved. And if you've been here for a while, you've seen that we started with static pages, and then we talked about dynamic, and then moving about responsive design, and then accessibility, and so on. But I think things have changed, and I guess you've seen that too. I found this article, and it's very insightful about how people are using Gen AI in 2025. And it has changed, because they made a study in 2024. And how people is using Gen AI today is for personal and professional support. This article mentioned people are using it for therapy, organizing their lives, improving education, content creation and editing, learning and education again, creativity and recreation, and so on. So this is how people are using Gen AI. And for me, my perspective, my opinion, I think people are asking for help. They want to be heard, and they're using these tools to answer questions, right? But this is an interface they're used to. This is when they go and ask for a question, they go here. They go to ChatGPT, they go to Google, they go to Claude, and they just ask in a natural language a question. And this is how the AI is redefining the interface that the users are getting used to. But I think this also creates a challenge for us, because these big AI models are trained with information that might not feature your product which has an interesting value, or the knowledge that your product has, or your organization knowledge. So it's not there, most probably because these models are generic. And I think this is where an opportunity lies, and what I want to talk today. So at Orama, we have been thinking, like, how can we enhance this? Like, how do we enhance the user experience with it? And we are React developers. We create these applications. We create these sites. Why don't we match the interface that the user is already being used to? This is just an example of some of the mockups that we have. And it's the same kind of experience that the user is having with other cloud-based solutions. And this is a way that I'll have the content. I mean, I'm the owner, and I can provide the same experience. You have a question, I can provide that. But also, if you saw in the chart of the article, there's no shopping. Like, people are not using Still for shopping. And I think that's another opportunity. Like, maybe we haven't figured out how to sell more in a natural language way. This is a mock-up we're creating, like, show me more like this. Like, if you're coming to Miami, what should I wear? That's the question that I like to get answered. Like, I want to go to an e-commerce or any other type of product and ask these kinds of questions. And yeah, this is the experience that I think we're moving forward. And as I mentioned, the browser. Like, why the browser? Because it's a platform that itself, it has evolved to make this a platform possible to create AI solutions. And what are these things that are helping it? We have Web GPU that is now standardized within Safari, Mozilla, and Chrome. So this make easy to run models with GPU. We also have WebAssembly, which it's not new, but it provides us this almost native performance in the browser. And of course, the privacy. depending of the industry that you have of your product or your service, some things you cannot send it over to the server. You need to be careful on that kind of information, and the browser already provides these kinds of privacy, not living outside the browser. And I think one of the most important things is the universal access. There's like 5 billion internet users already there, and it's very, you can run it on any device that can access a browser. So we have advantages here that we as React developers, we're already used to creating in the browser. And also in the panel, you heard all of this. And so, okay, so I can use the browser, but how? How can I use these models? And I want to be very specific that it's WebAI because it's not just LLMs, it's other type of models that you can run, like object detection, audio, and classification, and many other tasks that are not just for LLMs. And some of these libraries are like TensorFlow.js, so you can run in this one an object detection model. There's, of course, Hugging Face has its own library, which is Transformers.js. And it's very similar to the one that they have for Python, and you can use state-of-the-art machine learning models in your browser. So you won't have to spend a penny on cloud-based LLMs or any other type of model that your application might need. There is also this amazing project called WebLLM. So this is very similar to the ones of the cloud. And if you see how it's written, it's very similar to how you already use ChatGPT in the cloud. Like, it's really similar. It's just using a different package. So I think we're also removing friction on how we already using these things. And another one I want to mention is Chrome has this experimental build AI API they're building. They're actually looking for people to test it. This was presented in the Google I/O last year. And it's already there as an experimentation that you can use in your browser. It's like right now you can do window.something, document.something. You can do language model.something. And then what are they focusing on the task? Mostly prompt APIs, writing assistants because you want to summarize, you want to rewrite something, and you can create prompt extensions. So it's available for you to just create things like this. And of course, translation API. These ones are available, and if you want to give it a try, this is how easy it might be. As I mentioned, it's still experimental, but you can try it right now. So we have these options, but we still haven't done anything new, right? It's the same as using a cloud. Like, it's just using a model in the application. We need another thing that we need to fix, and that's the knowledge. How do I provide my product knowledge, my product value to these models? And there's many ways to do so. You can fine-tune a model and train it with your data, but that's expensive and also requires some set of skills. But there's another way that you can do this, and this is basically, there's two ways to do this. One, it's maybe you have heard of it, called RAG, which is Retrieve Augmented Generation. And RAG is very popular because these models hallucinate, right? They're generic purpose models, and if they don't know the answer of something, they might just make it up. But what RAG does is that it will provide an external source of data. And then when a user asks a question, you would just provide that information that is relevant to that query. And you might say, well, I can just import a PDF and then ask the questions. You could do that, but there's also constraints within the context. And also because what if the LLM just focuses on something that has nothing to do, and then the rest of the answers will not make sense? So why just don't we just provide the information that we need? And that is basically RAG. And so what does it mean? I mean, what do I need to do to use RAG? First off, there's different kinds of RAG. The term-based one is very similar to, I believe, what querying would be, or you might be related to, which is just look for anything that has this term. So for example, if I'm looking for React, it will look for the information just with React, right? That's the only information that I want. And that's term-based retrieval. But there is another retrieval called embedding-based, which is basically how most of the things, and it's a new thing, at least for me, it was, because it would be based on the understanding. It would be based on the meaning of the actual word. So for example, if a user is looking for React, I know that maybe Tanstack is related. It doesn't say React, but I know, or the computer itself knows, that it's within the same meaning, because it's going to provide an answer that is going to be relevant to the user. And this is, embedding would be basically having a word, and then this is a very simple two-dimension graph, right? I have cat, kitten, they're very close because they're close in meaning, and then there's other words that are in different coordinates. But imagine that this is basically a dimension of, and maybe this vectors is like 1,3, something like that. But vector or embeddings itself, you'll have 384 vectors. So that thing, that vector, that array of numbers, is the meaning of the paragraph, of the sentence, of the token that you're embedding. So what we're going to do is basically this. We're going to first need to index all of our data in a way of embeddings. We're going to use this method. We could use term-based, you can use hybrid, but I want you today to show you how embedding is done. So you have your data. And maybe, again, if it's a big PDF or a big whatever, you need to chunk it because we will face the same thing. You're fitting a lot of things, and you just need, when you ask a question, you just want the things that are relevant. You don't want the whole PDF. You just want the relevant chunks. That's why we're going to come into a process called chunk. And this might be, like, it's very experimental. You might do characters, you might do paragraphs, you might do whatever works itself for your company or for your data is the thing that you're going to do. And once you have those chunks of that information, you would embed them. So the chunk, that whole paragraph, sentence, word, whatever you chose to chunk, is going to be transformed into vectors. And we're going to use a special kind of database, which is a vector database. So that vectors are going to be stored in that vector database, and that's going to be our external source when using RAG. Perfect. So let's say we index our data. We have it. How do we query? We're going to go into a kind of similar process. I have my users input, the query. They're looking for this. This thing, I need to transform it into an embedding too, so that I can actually find what is relevant, because I cannot compare strings with vectors. So I need to transform that same thing, of course, using the same model, because if not, it's not going to make sense, right? So I have my input query. I transform it to an embedding, and I find the match. There's many algorithms for this, and of course, there are many tools out there that you could use. So I'm going to show you a very manual thing, because this talk was client-based, right? So I'm going to try to avoid using other solutions that are not client, but of course, I'm going to provide you others that might work. And then finally, once it retrieves that information that matches, that's when I'm going to use my LLM. I'll have the context. I have retrieved everything that's relevant to that query, and now I can use the LLM to answer as a human, right? Because that's how they're used to, and that's what they're good at, these LLMs, answering with a human language. And that's basically RAG and what you do with your data. If you want to see how I did it on the browser itself, Hugging Face Transformers has a model called feature extraction, which is the one that I'll be using to embed. So what I'm doing is I have this instance of this embedding model that I'm using from the Transformers library, and I'll just pass in, I'll just have this model. This is the one that I'm using. Then I'm going to generate the embeddings. And I already have my model defined, and I already have the text that I need to embed. Could be the query, could be the new data that I want to add. So I'm going to pass in the text, and I have my model. I'm going to pass the text, and then this is some things that are needed for this specific model of embedding, which is basically it's going to do the embedding of each of these tokens or sentence or whatever, but it's going to look for the mean of those. So that's what it's doing. And normalization is because I want all the vectors to be the same size. And with that, I'll have my query, my data embedded into a vector or transform into a vector. And this is how it would look. So today, I want to present a solution that I just came with, which is a learning platform. How could I make a learning platform be similar to what the user is used to? And this was, I had data which was related to courses. I have some curses that I can provide to my user. And this is how it would look in the index DB that I stored. In the previous talk, we heard about pglite. I didn't use that one, but I did use IndexedDB from our Chrome browser. And so if I want to print what I have there, this is what I have. I have the text, which is basically the information that I embedded. And the vector, it's all a representation of that. That is how it looks in the database. And when I get it back, I'll just need the text, because the vector is what I need to compare. And then just finally, once that I have that, it would go and look the find similar. So I'll go into my vector database, find anything that's similar, and then just return with that similar context, which is the one that I'm going to use to answer my user's query or question. And this is basically a RAG. This is, it's in a very manual way, because as I mentioned, we're using models in the browser that have, of course, limitations. But you could use RAG like this and store it in an IndexedDB, or in pglite, as another talk they mentioned. So yeah, it's a way that you could use RAG, and it's client-based. You're not using any cloud infrastructure for this. But remember I mentioned models hallucinate, and there's another way that you could fix this. And the other way is agentic pattern, which is basically agents. So for example, right now, if you go to ChatGPT and ask for something, there is an option that would look into the web if it doesn't have that answer right now. And that is basically an agent. An agent has a tool. An agent has a function. An agent has something that it can do when the goal cannot be accomplished. So the goal of your agent or your chat or whatever could be to answer the question of the user. And if you don't have that information, it's going to look for tools, functions, anything that helps accomplish that goal. That's basically the agentic behavior and what could help on your models. And in this implementation that I did, I created just 3 functions that this model has available. So if I'm a learning platform and I have courses, of course, maybe my user asks, like, I want to learn something. But what if my user wants to give a purpose to it? Like, you know what? I want to apply to this job. What courses can you provide me? So it's very different. It's a complex question, but you can prepare your platform for it. You can create an agent like, hey, if the user provides a job description, find out what are the things, what technologies we can help with. So my first function does that. Then my second function, it's going to find the courses. So I have the relevant technologies from the job description. And then I'm going to find what do I have in my platform that match that. And then just finally generate the learning path, which I already had. I had this learning path. I have this solution, but I didn't orient it to my user. So this is what the agentic behavior is doing right now for this platform. So a little demo, I'll show you, of course, the code and everything, just for the sake of time. So it's just, as I mentioned, a learning platform, and the user is asking to apply for a job, and it's going to paste the description of that job. So it's going to take some time. So, and then it says, OK, I detected this is a job description. Let me prepare like a learning path. And so I have all these courses. I have this path. I had that UI already, but I didn't use it in a purpose that would give meaning to my user. So I provided all of this learning path with the data that I already had. And this is basically the power of creating these new interactions, how the user is expecting, how the user is asking for help, how are we helping our users. And of course, we created this, but there's limitations, of course. Yes, in the client, you can run large language models, but of course, there should be certain size for it. In the cloud, you would still need, of course, an infrastructure for it, but you could use as many or as big as you want. I think one of the things that highlights the most on the client side is the privacy, which has been one of the key things that has highlighted the opportunity of creating tools like this. But of course, the vector database in my IndexedDB might not scale, probably. And of course, this is running on the RAM of the hardware, right? So depending on what you're using would be, of course, how can you use that same model or not. And of course, there are already tools out there for these problems that we mentioned. Vector databases, you could use Orama, which could help you index and query things. There's also Weaviate, which is another great solution that also provides solutions for agents. Supabase has PG vectors, so you could also use Supabase for this database, vector database, and Pinecone. But also for the agent framework, I needed to use a function, and I needed to use a lot of ifs and things. But you could rely on other libraries like LangChain, this one provides a more clean way to make your LLM look for those tools. There's also Llama Index, and of course the AI SDK from Vercel. But I think you will need an API for the model that you will use. But it would provide a smooth experience of using these agentic behaviors. And up until this point, we have solved the first problem. Our user is asking for questions. But what if the user never uses your platform? What if the user still uses any other cloud-based like ChatGPT or Google or Claude? And maybe you have heard of this model context protocol. So this is to prepare your website to provide these solutions to agents. So ChatGPT would have an agent that would go and look for things, but you already have an MCP server that would provide that solution. So you're covering your basis of, OK, my user might not going to come to my website, but I'm going to provide agents to find me. Before we were talking about SEO, like how do I feature in a Google search? But right now users, they're going to Google, but they're also going to these other places. And how are we going to face that? How are we going to take advantage of that? And this is a way we could do it, providing these tools, this way of interacting with our platforms for those agents. And this one is just a new one. I think it's also this week, agent to agent. This one is from Google. It's also a kind of protocol. But this is supposed to be a complement of the Anthropic MCP. And it's basically the same. It's agents talking to agents. How do I create a client agent or a remote agent that would help provide the tools and solutions that the agent that is fetching my information is asking for? So these are a way that we could also solve the other issue. And this is basically what I think we have the capability. We create these solutions. We create these applications. And I think we cannot just leave it to AI engineers. We also can provide all of the solutions with all of this knowledge, with all of these libraries that can help us leverage and do that. So don't you feel that because you're doing React, you cannot provide this kind of solution. I think it's also on our side to provide these kinds of solutions. And yeah, I think that's it. I hope this was an interesting talk for you. There's the slides, and thank you.